in this video, let's implement the game rule for the rook, like this one, right? It goes straight, right? Like that. In our previous, the last video, we implemented the game rule for the knight. So before that, I want to fix another thing here in our view controller here. View controller, this guy, view controller. What's the problem? Because whenever, right, I make a move, even though it's invalid, I always play the sound. That's the problem. So let me show you, because there's no sound on the simulator. That's the problem of this beta version of Mac OS. So I have to test it on my iPhone. So this guy, let me show you the problem. Okay, so when I make a like invalid move, I can still hear the sound, and we don't actually. That's because it's always played. Okay, so let me make a invalid knight move. Okay, you see, you can hear the sound, right? Again, yeah. So what we can do is we can use a guard here. Guard chess engine dot can move piece, right? From column from row to column and to row. So else we just return. Now, and we can remove the duplicate logic in this one. So let's jump to that thing. So now we can remove this one, right? Can move, then return. So we separated that. Don't want to duplicate. So moving piece. If got that, okay, so that's what we need. So now let me try it again. You can hear the sound. Okay, so now let me make a invalid knight move. Okay, there's no sound. Cool. Now a valid one. Yes. A black one. A invalid one again. Oh, I want to capture myself. Okay, so now a valid one. Okay, now we fix this sound problem. We can go back to our game rule of rook. So now let's go back to our simulator so you can see it. Yeah, to implement this guy, let's create the test case first, right? It's called test driven coding style, test driven. So here, let's create test. So rook rules. Yeah, rook rules. Let's do that. Knight rules. Okay, so for example, oh yeah, let's create an empty game here. So that's put the rook here, insert one rook. Okay, so we can also copy that one. So piece, so this time is 0 7, right? Image name, it doesn't matter, we are not using it for testing. White, true, this one is rook. Okay, so now there's only one piece, right? It's we can print out here. That's good thing. Yeah, we have that, right? So bye bye the simulator. We'll use our let's run this one. So because this, yeah, we click that, we want to bring up this guy. So now let's run this. We'll print out the board here. Yeah, this guy. So we'll make a copy and to show up our test case here. That's a good idea, right? Cool. So let's add another one for this guy. Also, we forgot to do that last time. So knight rule. So here there's a knight, right? So let's use from, so like knight here. Here is the destination, right? The destination. So we use like that. X means it's not doable. Okay, like or whatever. Yeah, let's use this for like invalid move. Okay, so here let's test, like for example this one. Okay, invalid move. So 0 7 to, that's xct assert false game dot can move piece from 0 7 to, okay, so 1 6. Now let's run it. Yeah, it failed. Now let's write our code, right, to make it pass. Let's go to our game engine. So our strategy is we'll create this time. Okay, let's remove this one, we don't need that. Can move knight. Okay, let's add another one here. But this time let's create a helper method, like something like that, to check, right, the intersections between the starting point and end point, right, is empty or not. Because if some piece, right, is blocking the root, then it cannot make the move. This will be used for pieces like rook and bishop. So function empty between. Okay, so empty between. Okay, empty between. Here we use the same thing here, same parameters, boolean. So we'll check a straight line, vertically, horizontally, and diagonally. So how do we do that? Let's check the horizontal first. Okay, so if from horizontal, so it means from row equals to row, right? If that, we can check. We can, oh, so we need to check. If we are using for loop, we need to know who is the minimum. Okay, so we can start from so let minimum equals min. Min now is from column and the two column, and that maximum equals max from column and two column. So now we'll what initial that used within is on. Oh, let's use a different name, please. So minimum column. Wow, Xcode is picky. Maximum column. So we'll read if maximum column equals is less than no, let's use this. Yeah, if this one minus minimum column, right? If it's less than 2, it means it's empty. Okay, so return true, right? It's empty. If that, okay, so otherwise we are using a for loop. Okay, for we'll for start from minimum I in minimum column dot less than maximum column. So we'll start from this one plus 1, right? And end with this one minus 1. So let's make it symmetric like that. Minus 1, yeah. So we'll check all of them. So now we can return piece at. So from row, right? And no, this one is the I, yeah, the column. Row is either from row or to row because they are same. If this one is not if this is nil, oh no, the logic should be if this is not nil, so we know we can return not empty, so we know it's not empty. Otherwise we'll keep going, right, to check. Then at the end we'll return true, like that. Yeah, by default will return false, not empty. And this is the case 1, right? Okay, so let's add another. So else if from column, right, equals to column. So this time, yeah, we'll do the similar thing like that. So minimum, okay, now it's row. Let's replace all these 2 rows. Oh, yeah, row. Okay, so I use that trick G. Okay, press G, command G. Okay, command G again, command G, paste, command G, paste. Okay, command G, paste, command G, paste, command G, paste, command G, paste. Okay, now this one will be from column. Now the row is I, right? So now we can add our function like canMoveRook, right? Make a copy of that. So like that. Now we can return. So we can use guard statement, empty between that from row, yeah, here, and 2 column and 2 row. So if that is not empty, we'll return false, right? Otherwise, canMove will return either this one equals 2 column, right? Or from row equals 2 row. 2 row. Yeah, that makes sense because rook moves around the straight root. So now we'll add this guy here, right? Case dot rook, right? Return canMoveRook from, again, from row 2 column and 2 row. Now let's go back to take a look of here and test it. So this one, let's comment out. Let's comment out this one so we can focus on this scenario is false. Okay, it passed. And this one, both of them, yeah. Now let's run in the simulator to see if it works or not. Let's move that out. Okay, so this guy, can we move to here? Yes. Can we move to here? No. Here? No. And what about here? No, because it's not empty, right? Okay, so can we do here? Yes. And what about this one now? Let's go here. No. Let's go here. Yes. Now can we do this? No. Can we go here? No, it's not empty. Let's go 1 step back. Okay, so let's test this one. Yes, I think it's fine. Thank you for watching. See you next time.